Okay, so let's do some practice in this last bit here. And that way we can get used to not only bring in some nomenclature and get some practice in that regard, but also now being able to name chiral compounds. And if we draw, let's start off with this. And so it's let's start off with something that's a little easy. Fluoride right there, right? And then that's a CH3. All right, now if we wanted to name this, we initially just go ahead and do our nomenclature for alkanes. We see that we have start numbering 2, 3, 4, 5. Based on our numbering scheme, we're gonna count towards the fluoride first, and that's going to give us our lowest number, and that's going to be a 2-fluoro-3-methyl-5. So that's pentane. So that's a pretty easy thing to come up with, right? So our root is pentane, and we move that pentane over there, right? And then that's that becomes our 3-methyl, and then that is our 2-fluoro, and we can then take these and copy and paste 3-methyl, 3-methylpentane, and 2-fluoro, and make sure this is still Make sure this is still alphabetical. A, B, C, D, E, F, G, H, I, J, K, L, M. Cool. Still got it. All right. And draw a dash there, and we can move this over here. All right. Now, we're not done, of course, because 2-fluoro-3-methylpentane is a racemic compound. In order to show that it's chiral, you've got to specify the stereocenters in the molecule. And we have 2. And we know we have 2 because this carbon has 1, 2, 3, and what I didn't draw, of course, is the implied hydrogen back here, and in this case, the implied hydrogen right here. All right. Now, how do we go about naming these chiral centers? All right, at the 2 position. So we're going to start at the 2 position. So the first one is this 2, and we got to decide whether it's an R or an S. And first thing we do is we do the numbering thing. All right, so the numbering things, we're going to go with fluoride, and fluoride's obviously going to be 1. And then we have to figure out which direction is 2. So in this case, we got CH3, and that's connected to 3 hydrogens. And in this case, we got C connected to another carbon, connected to a carbon. So this carbon right here is connected to a bunch of carbons. This carbon is connected to a bunch of hydrogens. So you always go with the one that's connected to the higher molecular weight crap. And 3 hydrogens is lower in weight than a bunch of these. So this is going to be 2. All right, and then it's just a competition between a methyl group and a hydrogen, and that's an easy competition. That becomes 3. And conveniently, this is already positioned so that the hydrogen is in the back, which means that we're already actually set up to start drawing our arrows, and 1 to 2, 2 to 3, and then 3 to 1. That gives us an R configuration, okay? So that one was relatively simple. And then we have one on carbon 3. Now, carbon 3, let me get rid of some things right here. There we go. Carbon 3, right there, that one is a little bit harder to name for us because the hydrogen is now pointing towards us. So you can do a couple of things, in your mental gymnasium, if you will. And just remember that if the hydrogen is pointing towards you, then the R and the S configuration must be backwards. You can also try to mentally swing this thing around, or here's a big one, you can just build a model, because you're allowed to have model kits in the exam, you're allowed to have all that sort of stuff, and then you can rotate a model around in reality. All right, and you can do this, you can make up your own line as to exactly how you want to actually do this, but one or the other would be my recommendation. Now, what we have to do still, no matter how you build this, is we have to then count, right? And so the first thing that we look at on this carbon is what they're connected to. And here we have a CH2, all right? And then over here we have a C connected to a C, connected to a C. and an H. So we've got C with 2 carbon connections and a hydrogen versus this one, which is a carbon with 2 hydrogens. So this guy, oh, I'm sorry, this has a fluoride on it. So that carbon fluoride connection clearly overcomes this anything. There's nothing even remotely as big as a fluoride on this carbon. So that narrows it down quite a bit. And so from this carbon's perspective, this one is number 1. And then 2, just like on our last one, we see this carbon's connected to 3 hydrogens, whereas this carbon is connected to only 2 hydrogens and 2 other and a carbon, right? So it's got a carbon connected to it, and this one has just 3 hydrogens, so because that's a CH2C, that's going to get priority. All right, and so that's going to be 2, and then that means that this is going to be 3, and your H is pointing out towards you. Now, again, I say the caveat that when you draw these, you can draw them in whatever orientation you want. 1 connected, 2 connected, and that goes around like that. But we're looking at this backwards. The rule is the hydrogen has to be facing away from you. And it's an easy enough rule to remember that if the hydrogen is facing towards you and your rotation is in the R direction, then you have to flip it to the S direction. All right? That's easy enough to remember. As long as you remember it. Otherwise, you're going to get it wrong. Remember, the true rotation must be with the hydrogen facing away from you. If you can remember that, to transpose it, so if the hydrogen is facing, you just go from R to S, then you'll get the right structure, all right? And so that is the name of this compound, 2R3S2-fluoro-3-methylpentane. Now let's go do something a touch harder, okay? And this is a good one. All right, so we're going to draw here, here, 2, 2. Then we've got a compound here, and then we're going to draw chiral center here. All right. So now I have drawn 2 chiral centers, and what do we want to name this? All right. Well, your first inclination may be to say, all right, well, our root word is going to be 2 carbons, 3 carbons, 4 carbons, 5 carbons. It's going to be 5 carbons. And your first inclination would be to be wrong, that I have tricked you. That is not the longest carbon chain in this molecule. The longest carbon chain is actually that connected there, right? So actually it's a 2, 3, 4, 5, 6 carbon chain that runs down through the system. So it's actually a hexane. That's the longest continuous carbon chain. And it turns out that we have a substitution at 1, 2, 3, 4, 5, 6. And it looks like if we actually look at it, we've got a methyl group coming off at 6, a ethyl group coming off at 4, a methyl group coming off at 2, and a methyl group coming off at 3. All right, so then how does this get named? Well, we are going to say it looks like in order to get the lowest number, you're going to want to count the opposite direction that I did. All right, so because you want to have the lowest possible numbers you can, and to do that, you count the other way. So we're going to actually go 1, 2, 3, 4, 5, crap. 4, that's going to be 5, and that's going to be 6, right? Because if I do it this way, then now I've got this substituent here that is a 3-ethyl group, and now I've got a 2-methyl, 4-methyl, and a 5-methyl, and you can try to convince yourself that that's a series of lower digits than if you were to count the other way. And so, of course, ethyl, and then you have these methyl groups here and here and then here. And so you have a trimethyl and you have a 2, 4, 5 trimethyl, and A, B, C, D, E. Ethyl is going to be alphabetically first, so that means that you got to do the 2, 4, 5 trimethyl. That has to come first. All right, and so trimethyl is second in the alphabet. Then we add on our 3-ethyl. And this word's a bit long, isn't it? 3-ethyl 2,5-trimethylhexane. But that's not a chiral compound, right? This is, I have drawn with chirality and omitted the hydrogens that are actually sitting in the back. Okay, so that's not the full name of this compound. It would be if I had not specified any sort of stereochemistry, but I did. So this is an enantiopure compound, and that means that we have to put in brackets, and those brackets are going to correspond to an atom at 3, be either R or S, and an atom at 4, which will either be R or S. Now comes the fun part of figuring out how to count these things, and this I think is a little trickier. So what I'm going to do actually is I'm going to redraw carbon 3. All right, and carbon 3 has a carbon coming off of here and then 2 methyl groups. All right, and it has an ethyl group coming off of it, and then it's got something that looks like that. All right, now we've got to number them. So first thing we do is we go out to the first carbon. All right, and in this case, let's make that even more obvious. In this case, this is 2 hydrogens and a carbon. All right, and so that's probably going to be lower than these two, because if we come out to this place out here, we've got 2 carbons and a hydrogen. All right. Of course, if we come out here, we also have 2 carbons and a hydrogen. So so you can't really tell these two apart. Those are so far identical, which means we have to continue drawing these. And if we continue drawing these, we can see that these are actually CH3s, and this is a CH3, but this actually keeps going. This keeps going, and you get additional carbons. This is actually a carbon here, and this is a carbon here. So that means all the way out here, you've discovered this is the higher priority branching, because those then go off to carbons, whereas these all terminate in CHs. So that gives us our priority. This must be the highest priority, followed by this, followed by that, and then the unwritten hydrogen that sticks down in the back, okay? Which now makes assigning this carbon a tad easier, because now we can draw from 1, to 2, to 3, to 1 again. It's very unhelpfully making that a stick. All right, which makes this an S. All right, so the 3 is an S. All right, now let's look at what 4 is. So 4, if we go back over here, we've still got to do the same sort of prioritization as before, except, of course, I've drawn a lot of crap all over it, which makes it a little hard. But we can do the same sort of thing. So let's then redraw that chiral center. So you know what? I'm going to take this. Now that that's done, I'm going to shrink it so it's now over here. And I'm going to redraw that chiral center where we have a carbon that is like that. It's got 2 methyl groups. We've got a carbon here, and that's a CH3. And a carbon here, and it goes on to a series of other uneventful things, or rather eventful things. And if we look at this, the hydrogen's now in the back. If we look at this, all right, this is a CH3, probably going to be the lowest configuration. This goes to a C, and this goes to a C. In this case, both of these C's are connected to CH3s. So we have to go pretty far out. We have to go to all the way here. So we have to go to the first and then second, and then look at the protons, right? And we have to do the same thing here. We have to go first and then second. But actually, this sort of solves our issue right here, because this has 2 H's and a carbon, whereas this has 3 H's, which means that it's pretty clear at this point that this chain is the higher priority. So we can then number this as the highest priority 1 right here. All right, and then now the question is what we put over here. So that's 1, and that must be 2, and that must be 3. And of course, the hydrogen in the back is 4. And we can draw our our little circles here. The hydrogen is in the back, so we can directly take it from there. And that is an S. All right, so 3S, 4S, 3-ethyl 2,4,5 trimethyl hexane.